Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on LTI system using Fourier transform and Laplace transform. Linear time invariant system are characterized with the help of differential equation, impulse response, block diagrams, state variable description, transfer functions. Differential equation, it is used to represent continuous time, linear time invariant system. It relates the input and output of the system. When we applying the input function to the differential equation, which produce the output as y of t. System transfer function is nothing but ratio of the output to the input. H of s is equal to y of s divided by x of s. Frequency response, h of omega is equal to y of omega divided by x of omega. When x of t, while we taking the Fourier transform, we can get x of omega. For frequency domain analysis, h of omega, which produce the output as y of omega. While we applying the inverse Fourier transform of y of omega, which produce the output as y of t. Condition of a linear time invariant system to be causal, h of t is equal to 0 for t less than 0. Linear time invariant system to be stable, summation k is equal to minus infinite to plus infinite. Modulus of h of k should be less than infinite. The impulse response is the output generated by the system when the unit impulse is applied at the input. X of t is equal to del of t can be applied to your LTI system, which can produce the output as y of t is equal to h of t. X of s is equal to y of s divided by x of s. While we applying how to find out the impulse response of the system, while we taking the inverse Laplace transform of h of s, we can get the impulse response of the system. Del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. Fourier transform. Fourier transform can be applied for both periodic and non-periodic signals. It can be represented in frequency domain. It provides the effective reversible transformation link between frequency domain and time domain representation of the signal. The spacing between spectral components becomes infinitesimal and hence the frequency spectrum appear to be continuous. Periodic signal has a fixed time period of t0. This is the time domain to frequency domain representation. The whole wave can be represented as t in terms of 1 kHz. In frequency domain representation can be given. If the wave is divided by 2, it can be represented as t by 2 in terms of frequency domain representation in terms of 2 kHz. Right? While we applying the Fourier transform of time domain function s of t for analysis function, which can produce the output as s of f. For synthesis function, when we applying the s of f inverse Fourier transform, we can get s of t. Therefore, s of t and s of f forms the Fourier transform pair. Laplace transform. Laplace transform represents continuous time signal in terms of complex exponential, that is e power minus st. Laplace transform can be used to analyze the signals or functions which are not absolutely integrable. Continuous time signal can also be analyzed effectively using Laplace transform. Laplace transform of impulse response is called a system function or transfer function. Laplace transform is divided into unilateral Laplace transform and bilateral Laplace transform. For the time domain function x of t, we'll be taking Laplace transform x of s. H of t, Laplace transform h of s. Y of t is equal to h of t into x of t. While we taking Laplace transform, y of s is equal to h of s into x of s. While we applying inverse Laplace transform, we can get y of t is equal to h of t into x of t. This is the steps to find the impulse response of the system. First, for the differential equation, we are applying Laplace transform and then finding the algebraic equation and then solving for roots. Finally, we can take the inverse Laplace transform of the system transfer function. We can get the impulse response of the system. Next one, any input can be represented by using the impulse function is nothing but convolution integral. X of t can be applied to LTI system, which can produce the output as y of t. Y of t is equal to t into x of t. Therefore, y of t is equal to x of t into h of t. Next one, these are the basic signals: unit step signal, unit impulse signal and unit ramp signal. U of t is equal to 1 for t greater than or equal to 0, 0 for t less than 0. Del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. R of t is equal to t for t greater than or equal to 0, 0 for t less than 0. These are the some of the graphical representation of basic signals. Now we can see the Fourier transform of x of t is equal to u of t. X of f is equal to integral over minus infinite to plus infinite x of t into e power minus j 2 pi f t into dt. While we applying the unit step signal, we can get x of f is equal to 1 divided by j 2 pi f. For any transform, we are applying for any transform of unit impulse function. Therefore, x of f is equal to 1. Del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. Next one, Laplace transform of unit step signal. X of t is equal to u of t, which is equal to is nothing but x of t is equal to r of t. Therefore, Laplace transform of x of t into u of t is nothing but x of s is equal to 1 by s. X of t is equal to r of t is equal to, while forming uv method, therefore t into u of t, we can apply the limits from 0 to infinite. Therefore, x of s is equal to 1 divided by s square. Now we can find the output of the system. H of t is equal to u of t. X of t is equal to e power minus 2t into u of t. H of s is equal to 1 by s. X of s is equal to 1 by s plus 2. Which is equal to h of s is equal to y of s by x of s. Therefore, y of s is equal to h of s into x of s. Therefore, 1 by s into 1 by s plus 2. Therefore, which is equal to a divided by s plus b by s plus 2. S is equal to 0, we can get 1 by 2. S is equal to minus 2, we can get minus 1 by 2. Therefore, y of s is equal to 1 by 2 into s minus 1 by 2 into s plus 2. While applying the inverse Laplace transform of above function, we can get y of t is equal to 1 by 2 into u of t minus 1 by 2 into e power minus 2t into u of t. Next one, we can see the assessment. The system transfer function is given by h of s is equal to y of s divided by x of s. Dash relates the input and output of the system differential equation. What is mean by impulse response? When the unit impulse is applied to a linear time invariant system which can produce the output as h of t. The condition of an LTI system to be causal is given by h of t is equal to 0 for t less than 0. Fourier transform of unit step function is given by, therefore x of f is equal to 1 divided by j 2 pi f. List the types of Laplace transform. It can be divided into two types, unilateral Laplace transform and bilateral Laplace transform. Laplace transform of unit ramp signal is given by x of s is equal to 1 by s square. LTI system are characterized with the help of differential equation, block diagrams, transfer functions, etc. Thank you.